Today we're going to learn how to add and subtract radicals. Adding and subtracting radicals follows the same properties as you do when you add and subtract fractions. In fractions, if you recall, you have to have a common denominator. And once you have a common denominator, you add and subtract the numerators, bring over the denominators, and then simplify. Well, it's kind of the same premise for radicals. You need to have like radicals in order to add and subtract. So let's talk about like and unlike radicals. Like radicals would mean that what is under the radical sign is the same and you're using the same root. For example, square root of 3 and 2 square root of 3 would be like radicals. They're both square root of 3's. 5 cube root of 2 and 4 cube root of 2 are like radicals because they both are cube root of 2's. Unlike radicals would be square root of 3 and square root of 5. Yeah, they are both square roots, but one square root of 3 and square root of 5. So you're looking for what's under the radical to be same, and square root of 3 and cube root of 3 are not alike because they don't have the same root. So in order to be like radicals, you have to have the same index, which basically, if you can recall from the very first set of notes, is the root. So you have to have the same index, which again is your root, and you have to have the same radicand, which is the guy under the radical symbol. Okay, so let's add and subtract radicals. Remember, you have to simplify all radicals and then add and subtract the coefficients of the like radicals. The coefficients are the guys on the outside, and keep the same index and radicand. But again, you cannot add or subtract unless you have like radicals. So let's take a look at number 1. 6 radical 6 plus radical 54. Do I have like radicals? No. So I'm going to try to simplify them to see if I can get like radicals. So I'm going to actually put my perfect square root list over here to the side to help myself. Alright, 2 squared is 4, 3 is 9, 4 is 16, 25, 36, 49, 64, 81, 100, 121, yada, yada, yada. Okay, let's see. 6. I can't simplify 6 anymore because 4 is the smallest one and it won't go into it evenly. So I'm going to bring down 6 radical 6. 54, let's see. 54 would fall right here. 49 can't go into it evenly. 36 can't. 25 I know can't. 16 times anything give me 54? No. Can 9? Oh, yeah. We have 9 times 6. Well, right now it looks like I'm going to be okay, because if you realize, I may have a 6 underneath the radical sign for both. So let's see what I have. I have 6 radical 6 plus square root of 9 is 3, so I have 3 radical 6 here. Well, I have like radicals, so 6 radical 6's plus 3 radical 6's will give me 9 radical 6. And I check to see if I can simplify, and radical 6 can't be, so I'm done. Let's go on to number 2. Radical 125 minus radical 20. They're not like radicals, so I can't subtract, so let's see if I can simplify them to get them to be like radicals. So 125, if I start down here and move my way up, finding the biggest perfect square that'll go into 125. Oh, you're right, 25. 25 times 5. Minus, what's the biggest perfect square root that'll go into 20? You're correct again, 4 times 5. Now if I take a look at this, it looks like I'm going to be okay because they both have a 5 now under the radical. So, square root of 25 is 5, so I have 5 radical 5. Minus, square root of 4 is 2, so I have 2 radical 5. 5 radical 5's take away 2 radical 5's gives me, you're correct, 3 radical 5's. So let's move on. In number 3, I have some variables. Oh, I'm not going to get intimidated because I'm pretty good with variables now, so we're just going to move on. Can I simplify radical 3? You're right, I can't. So I'm just going to bring it down. X radical 3 plus 75x squared. Oh, 75 could be 25 times 3. And isn't it true that x squared is a perfect square root? So I'm just going to rewrite them. Okay, x radical 3 comes down. Square root of 25 is 5, so I have plus 5. Square root of x squared is x, so I have 5x radical 3. So 1x radical 3 plus 5x radical 3 gives me, you're correct, 6x radical 3. Okay, let's move on. So now I'm subtracting, but now I have cube roots. And I'm not going to let that intimidate me because cube roots are really not that difficult. And if you look at number 4, you already have like cube rooters. For both of them, you have cube root of 2. So it says subtract that guy from that guy. So if you remember from Unit 1, the second guy has to come first. So we're going to write it as 5 cube root of 2 minus cube root of 2. All right, 5 cube root of 2, take away a cube root of 2 gives me, well, 5 minus 1 is 4 cube roots of 2. And I'm done. That's how easy that one was. Okay, let's go on to number 5. Radical 27 plus radical 50 minus radical 8. Well, I can't add or subtract any of that because I don't have like radicals. So we're going to need to simplify. So 27, we're actually going to use, you're correct, 9 times 3 because we're doing square root again, plus 50, we're going to use 25 times 2, and 8, we're going to use 4 times 2. So let's see what we've got. Square root of 9 is 3, so this guy becomes 3 radical 3, plus square root of 25 is 5, so now I've got 5 radical 2, minus square root of 4 is 2, so I have 2 radical 2. Well, the only two guys I can put together are the 5 radical 2 and the 2 radical 2 because they're the only guys that have like radicals. So I'm going to bring down the 3 radical 3. 5 radical 2's take away 2 radical 2's is, yes, you're right, a positive 3 radical 2's. And there's my answer because I can't add any further because I don't have like radicals, and I can't simplify radical 3 or radical 2, so I'm done. Let's go on to our last problem for the day. 4ab radical 2b minus 3a radical 18b cubed plus 7ab radical 6b. Okay, can't add and subtract them because I don't have like radicals, so let's see what I've got. So, 2b can't be simplified, so I'm going to bring down 4ab radical 2b minus, 18 can be simplified, so I have 3a, perfect square root to go into 18, you're correct, 9 times 2. Is b cubed a perfect square root? No, but remember what we discussed. If you go down 1 to b squared times b squared will be a perfect square root, and b squared times b is b cubed, so it makes sense. Plus 6b, nope, that can't be simplified, so 7ab square root of 6b. All right, let's see what we've got. 4ab radical 2b comes down. Square root of 9 is 3. When 3 meets the 3 in front, I get 9. Can't take the square root of 2. Square root of b squared is b, so I end up with 9ab radical 2b. Okay. Plus 7ab radical 6b. Now everybody's an AB, but I can't put them all together because everybody's not a like radical. The first two are 2b's, the last guy's is 6b. So the only guys I can put together are the first two. So 4ab radical 2b minus 9ab radical 2b is going to give me negative 5ab radical 2b, and then you bring down the plus 7ab radical 6b. Even though 5 has an AB with it and 7 has an AB with it, you have to have like radicals to put them together. And in this case, you don't. So, that's my final answer. And that was our last question for today. Have a good evening.